Question is, which of the following are not dependent on the applied loads? The applied loads P is not dependent on which of the following: elastic strain and creep strain and carbonaceous strain. The applied, it depends on the strain that is causing in the material is dependent on the applied load P. Whereas in case of drying shrinkage strain, it is not dependent on the applied load. So option C is correct. We have to find out not dependent. So option C is correct. Here the question is, in a pile of length L, the point of suspension from the ends for lifting are located at for maximum bending moment condition. So if you take a pile is suspended at two ends, the maximum bending moment condition is going to occur if you suspend at a length of 0.207. So option A is correct. Is a double U-type butt weld used to connect two plates 180 mm by 18 mm each when a moment of 13 kilonewton meter is acting. The amount of stress developed will be, we have to find out the stress that is developing in this double butt weld. So we know that sectional modulus is equal to 18 into 180 square by 6, that is 97.2 into 10 to the power of 3 millimeter cube. We know that permissible bending stress sigma bf is 165 newton per millimeter square. Whether the actual bending stress amount developed in this particular case we have to calculate. Sigma bf calculated is the amount of bending moment that is caused is 13 into 10 to the power of 6 divided by 97.2 into 10 to the power of 3, that is equal to 133.74 newton per millimeter square. This is the amount of stress that is developed in this butt weld. So the actual permissible stress that is developed is, actual permissible stress is, it is less than 165. So 133.74 is correct answer. If it is greater than that, this is the permissible. It should not be greater than this. So 133.74 is correct. Is, find out the velocities of the groundwater flow using the Schlichter constant is given as 400, and the dynamic viscosity is 1 at 10 degrees centigrade. Effective size of the particle is given as 0.1 millimeters, and the hydraulic gradient is given as 1 in 80. So from the Schlichter constant, the velocity of flow is given as V is equal to Ks d square by m, where K is Schlichter constant and the S is hydraulic gradient, D is the effective size gradient, hydraulic gradient, Schlichter constant, and M is the dynamic viscosity. So by substituting all these values given in the data, we will get K is 400, S is 1 by 80, D is 1 by 0.1 square, M is 1, D is 0.1. It has to be on the top. Sorry. So we will get 0.05. That units has to be meters per day, in the meters per day. The units of effective size in millimeters. So 0.05. Option A is correct. And is, a country has a population of 9 million and the growth rate is given as 1% per year. What will be the population of the same country after 30 years? So we have to find out after 30 years what will be the population. And the after 30 years growth rate R is 1%, that is 0.01. So the population at T is 1 plus R whole power T into actual population is 9 million is given. So 1 plus 0.01 whole power 30 into 9 million is equal to 12.13 million. So the relevant answer for this question is option C, that is 12 million. So option C is correct. The question is, if the flow net of a coffer dam foundation has a number of flow channels as, so number of flow channels is given as 6 and 16 number of equipotential lines. ND is given as 16 numbers with a head of water loss during seepage being 6 meters. H is given as 6 meters. Through a foundation having permeability coefficient is given as 4 into 10 to the power of minus 5 meters per minute. The seepage loss in meters square per day per meter length. So we have to convert into these minutes into days. 4 into 10 to the power of minus 5 meters per minute is 1 by 60 into 24 days. So 4 into 10 to the power of minus 5 into 60 into 24 meters per day is the permeability. So what we have to find out, the seepage loss. Seepage loss per meter length Q is equal to KHNF by ND. So K is permeability, 4 into 10 to the power of minus 5, 60 into 24, H we know 6 meters, NF we know 6 divided by ND we know 16. So this give us 12.96 into 10 to the power of minus 2 square meters per day per meter length. So option C is correct. The question is, a vertical triangular area with vertex downward and altitude of 4 meter has its base laying on free surface of a liquid. So vertex downwards, it is of, let we take H is equal to 4 meter is given and base B we can consider. So the center of pressure below the free surface is at a distance of, the center of pressure below the free surface is equal to x bar plus I y by ax bar. So we know the x bar is going to be at distance of h by 3 from this base, h by 3, that is h by 3, Iy is with respect to base b d cube bh cube by 36 divided by area is half base into height into x bar is h by 3. So by doing the mathematical calculations we will get h by 2, that is equal to h we know 4 by 2, that is 2 meters. So the center of pressure below the free surface is going to be at 2 meters from the base, 2 meters. Option B is correct.